All right, so infrastructure as code is evolving. We also see there are different use cases for infrastructure as code. In the next slide, I'll go into some of those use cases. But the life cycle is different depending on where in the technical stack your infrastructure as code lives. And then at enterprise scale, which there are just so many sources of complexity. You have you might provision infrastructure with your infrastructure as code, but over time, the infrastructure is going to get out of sync with your code. You might run your pipeline frequently, you might not. There's going to be configuration drift. And if you don't have the environment locked down from manual changes, then that configuration drift can cause a lot of problems. Packaging reusable patterns is really important. We have ServiceNow and HashiCorp's Terraform plugin, which is a great way to package Terraform reusable patterns or Terraform modules. But other infrastructure as code tools haven't really done it as well, but it's still a question that we always need to ask when we're adopting a new tool is how do we make this reusable so we can adhere to the don't repeat yourself principles. Governance and governing infrastructure in general in a large organization really consumes a lot of cycles. Right now, there's a move to shift everything left to basically apply those governing policies as early in the pipeline as possible so that developers and infrastructure operations engineers are able to apply those policies at scale and give feedback early on. And then just the nature of the beast is we have applications are kind of usually one of the last things that are deployed. We have infrastructure that supports them. Sometimes that's deployed earlier, sometimes it's deployed at the same time. But keeping all of that in sync across different layers is also a source of complexity. And the different layers in an organization can lead to many different challenges. So when we talk about infrastructure use cases, I like to think of this as kind of a spectrum of infrastructure that really doesn't change once it's laid down. You can think of your cloud, your foundational infrastructure, your organization, your shared VPC, and then the next layer up above that might be your project structure. What's the standard GCP project going to look like for everybody who gets a GCP project? What IAM permissions? What permissions for the host project do they have, et cetera, et cetera. Then you get to the application infrastructure layer. You might have supporting infrastructure that gets deployed along with an application. You can think of a pub subtopic that gets deployed alongside of a container on GKE. And then finally, you might have event-driven infrastructure, and typically that's not the best use case for declarative infrastructure as code. You might have some application resources that are dynamically creating what's considered infrastructure, but even when we talk about cloud resources, infrastructure can take ephemeral forms as well. So when we talk about cloud infrastructure use cases, most of the time when we talk about infrastructure as code, we're looking at the bottom three layers. But it's been also kind of, it's a tempting anti-pattern to want to reuse your Terraform code to do something dynamically. Maybe you want to create an application where press a button and it spins up some cloud resources for a period of time, maybe a sandbox environment or something. So dynamic infrastructure is it's kind of an interesting, has kind of an interesting spot here as well. And I'll get into why I bring that up in a few slides when we get to KCC. So there are two tools that we're talking about today. Terraform, which is usually deployed through CI/CD pipelines. You have your pipeline, you run your Terraform operations, and the output is your infrastructure. And then Kubernetes config connector, which takes a different approach that really adopts the Kubernetes ecosystem as its main deployment mechanism. So Terraform is really the tried and true workhorse of infrastructure as code. It's been around for a few years. In the really early days, it was changing so fast that it didn't really hold the kind of like stable place in infrastructure as code that it does now, but now it's really solid, has a very extensible ecosystem. The Terraform framework, you could say, has a pluggable backend called providers. So you see different cloud providers or even any kind of service that has an API can essentially write their own provider for Terraform, which makes Terraform very extensible. That's why we see it in multi-cloud settings. You learn how to use the tool once, you can write Terraform modules for GCP or AWS or whatever your favorite cloud provider is. And then it's modular by design. And by modular, I actually mean, how do we package this this piece of code here? Let's say we have a pub subtopic and we want to enforce a naming convention. We might take an input like the environment, the name of the application team, or some kind of asset tracking ID, and enforce that to be a label on this. Terraform has a very simple concept of modules. It's one of the simplest reasonable constructs that I can think of in software that makes it really easy to do things like that. The way that Terraform works is essentially it provisions, as I described before, it takes your code, you feed it into this Terraform binary. Terraform figures out which backend it needs to use. Those backends are called providers, and the provider essentially just makes API calls to the actual GCP environment. Typically, you see this in a deployment pipeline, so there's some kind of trigger. It could be a manual infrastructure as code operator presses a button. Oftentimes, we're seeing deployment repositories, Git repositories, as the main driver of deployments. So you usually have kind of a thin wrapper for the deployment pointing to a particular environment, and you have a standard process. Your plan, Terraform plan, takes the code, it takes the state, which is basically Terraform keeping track of what it's created in the past, and then it makes calls out to the target environment to figure out what is the actual state in the environment. It puts those three things together and figures out what operations it needs to apply in order to achieve the desired state that's in the code. So we've seen kind of a very code-driven or config-driven through Git repository, which gives you some level of versioning to provision environments. There's one box I would like to highlight here, which is part of the shift left paradigm, and that's where we're using tools like Open Policy Agent, or OPA for short, to actually do some static analysis on Terraform plans and enforce things. Maybe you only want to allow a certain region, or maybe you want to enforce CMEKs, customer managed encryption keys, for all storage buckets that are created. You can have that right in the pipeline. It fails right away on the pull request and can't even be merged if you have those policies implemented. And that's pretty powerful, because now we're shifting this left. The only thing is, with Terraform and OPA, you don't have anything that's actually gating it on the API side for Google resources. So if somebody circumvents the pipeline, they can still go and create a bucket that doesn't have storage encryption, and you wouldn't know about it. And there's really no way to prevent it unless you're forcing everyone to go through the pipelines. So some common pitfalls. Terraform is not good at managing resources that were created by something else. It has mechanisms to kind of, it has kind of a escape hatch, so to speak, where you can import resources, but it's never been a core part of managing infrastructure with Terraform. So you have to run imperative commands. Usually those aren't part of the standardized pipelines. So it can be kind of a hassle if you have an environment where, let's say you have developers working, you give them console access, and you might want to give them some freedom, but you also have your Terraform pipeline. There can be conflicts. They can be kind of a hassle to deal with, especially in higher level environments. If there are resources and that get out of sync with your Terraform code, or there are some times when Terraform doesn't properly tear down a resource, and you kind of need to use some of those escape hatches to get back in. So Terraform doesn't really excel there. That's a common pitfall. Another common thing that I see is even though Terraform is considered multi-cloud capable, it's not an abstraction. So even if you want to set up a VM on AWS, that's an EC2, or a GCE instance on Google Cloud, the actual code that provisions that, or that you write as an infrastructure as code operator, is different. So it's not an abstraction layer. That's actually a feature, not a bug of Terraform, but it's a common misconception about Terraform. You do have to write different code for different environments. Configuration drift, this kind of goes back to managing existing resources. They're two sides of the same coin. When resources get out of sync with Terraform, it's hard to get them back in sync sometimes, sometimes impossible depending on the way the environment's set up. So that can be kind of challenging. If you don't pin your versions with Terraform, you can get out of sync because Terraform is an open source tool. It is rapidly evolving. The provider versions need to be pinned. The module versions need to be pinned. So that can cause some challenges, especially if it's a pipeline that you only run maybe once every month or two, or especially with higher environments, maybe you're only running it every 2-3 months, once a quarter or something. If you don't pin the provider versions, you can end up in a situation that's kind of difficult to handle, especially in higher environments. And then finally, Terraform is a little bit tempting to use for dynamic use cases because it has that cookie cutter reusable patterns, but it's not really that well suited for dynamic use cases. You can't just make an API call that provisions Terraform. You kind of have to build that machinery around pipelines to begin with. I'll step away from Terraform and introduce Kubernetes config connector. One of the reasons that I would like to talk about KCC today is actually that some of the complexities that come with the pipelines of Terraform kind of go away with Kubernetes config controller or Kubernetes config connector. And that's, I'll go into more detail there in a couple of slides, but just high level, what is Kubernetes config connector? Rather than writing your HashiCorp configuration language, KCC exposes resources with these custom kinds. So you can see kind pub/sub topic. It's part of the pub/sub KCC resource type API. And your configs are basically just look like any other Kubernetes manifest YAML. You have your API version, kind, metadata, and spec sections. And it makes it very familiar if you are already using Kubernetes to provision applications. So that's one of the interesting benefits of KCC is if you're already using Kubernetes and you flip the switch to enable KCC, you can essentially reuse your deployment mechanisms, whether you're doing something like GitOps with CD or you have pipelines that are already deploying your Kubernetes manifests. The way that KCC works is essentially when you call kubectl create or patch or apply or delete any kubectl operation on an object, you make a Kubernetes API call to the Kubernetes API server. There's a controller manager, which is basically a pod or a deployment that's running on your cluster when you install KCC. It basically watches for the objects that are in etcd. Etcd is like Kubernetes database. It's basically a key value database, but that's where the objects actually get stored. So the YAML that we saw in the previous slide gets put into etcd, and now there's a pub subtopic in etcd. So the controller manager checks, it checks about every 15 minutes. You can see that in the controller manager logs if you're ever interested in looking under the hood. And the controller manager goes and makes the API calls to create the Google Cloud resources. Basically tries to figure out what does it need to do, and it makes the API calls from Kubernetes itself, from this controller manager. So that has a lot of implications. You can do this in a particular namespace. You can basically map one project to a particular namespace on Kubernetes with a service account that can only manage the project that it's allowed to manage. So you don't have to have any super permissions in your pipelines. You can have it scoped explicitly to only be able to provision resources in a particular project with a workload identity binding. So it really changes the way that we think about deployment, because the pipelines go away and it pushes a lot of the security logic into Kubernetes itself. So a lot of organizations, this is an Anthos reference software delivery pipeline, but a lot of organizations are adopting kind of a Kubernetes approach for software delivery. Here there are basically three pipelines. The top one is the application development pipeline. Let's say you have your Java application, you run it through CI, you build a container, you push it to your container registry. Container registry generates an image shop, and then your platform pipeline is basically your delivery pipeline. So that's mainly your Git repository. The output is Kubernetes manifest, and with Git, basically whatever gets stored into the deployment Git repository will be watched by your continuous delivery mechanism. In Anthos, that's called config sync, which is a service that runs on the cluster itself, and it watches for a repository, and it basically maps resources to a namespace. Is kind of the simplest way to think of it. There's another one called Argo CD, which is pretty popular. They function very similarly. One's a push model, one's a pull model. So there are some slight nuances in the way that they need to be configured. But this middle pipeline here is kind of where the KCC resources would be slotted in. So you put your pub sub topics along with your application that gets deployed to the Kubernetes cluster, just as all of your other Kubernetes resources. So that's pretty powerful because if you're already using Kubernetes as your main application delivery mechanism, extending infrastructure as code is almost just a matter of flipping a switch and just including that in your pipeline. And then at the bottom here, there's a third pipeline which is out of band from the platform pipeline. So basically, you can write security policies with this tool called OPA. Those actually get deployed to the Kubernetes cluster and enforced on the Kubernetes cluster. You can also run that as part of a CI check. Let's say you open a pull request and you only want to allow storage buckets, cloud storage buckets, if it has a CMEK. So you can enforce that policy on the Kubernetes cluster itself, but you can also add it to the pipeline if you want to add some additional logic. But it ends up using exactly the same policy code in the pipeline or on the Kubernetes cluster. So KCC via Anthos Config Management. Anthos Config Management is the suite of tools that has a policy controller on the cluster. It's called Gatekeeper. It has config sync, which is a continuous deployment tool, basically mapping resources in a Git repository to a namespace is kind of the simplest way to think of it. And then KCC allows you to provision infrastructure through the exact same mechanism of Kubernetes manifest as we deploy other things. And just as a side note here, config sync is also exposed as a custom resource definition in Kubernetes. So you can use a Git repository to map your config sync objects to a Kubernetes cluster, and then that Kubernetes cluster can go off and fetch a whole tree of different resources and provision those other resources in other namespaces, and even provision your KCC resources. It's kind of powerful because it gives you a way to reconstruct or rebuild an entire cluster with several projects. You don't have to go clicking around different Jenkins pipelines in order to build out your different layers. So that's something I've seen actually work well in an enterprise setting. I was pleasantly surprised just how amazingly simply they were able to rebuild an entire cluster and all the infrastructure. As I was mentioning earlier, there's this concept of gatekeeper OPA policies, but the interesting part is before we would have our OPA code that would evaluate Terraform plans, maybe block a storage bucket from being created in the pipeline itself. We can actually run the exact same policy code in the pipeline before it's deployed, or we can allow that to get blocked on the cluster itself. So if you are allowing GitOps, which would be kind of like the CI/CD pipeline approach, or you're allowing other tools. I've seen Argo events and Argo workflows creating other resources. The gatekeeper policies will actually dynamically stop resources that aren't allowed to be provisioned before anything actually happens, which is quite cool because now you're not limited to just going through the pipeline, but you also have some policy enforcement without that supports the kind of imperative use cases, essentially. Now, a couple of unique KCC features compared to Terraform. KCC has the ability to acquire and abandon resources basically through a Kubernetes object annotation. That behavior is different than Terraform's, where you would have to run a Terraform import. So it's possible basically to configure your KCC resources. Let's say you want to tear down the cluster and rebuild it for some reason. You can actually do that. There are a few resources that can't be acquired just by the name, but the number of resources that you cannot acquire has become fairly small at this point. Terraform uses the common Kubernetes YAML config. So interestingly, rather than something like Terraform, which has its own templating and it has its own parameterization built into it, it uses kind of standard ecosystem tools, but it gives you access essentially to many different tools in the Kubernetes ecosystem. So you can use Helm, you can use Kustomize, you can use Argo CD, all of these things for your infrastructure code itself. And I think that's really powerful because the Kubernetes ecosystem is continuing to grow, continuing to develop. There is some fragmentation in terms of what tool to use for packaging. I've noticed, the Kustomize folks and the Helm folks have very kind of conflicting philosophies sometimes. Kustomize doesn't like any templating. They're basically overriding, with merges, Kubernetes YAML merges. So something to keep in mind if you are trying to identify tools for your stack. But it's I think that is a really interesting benefit, and that's one of the reasons that OPA Open Policy Agent is able to be applied the same way to your regular Kubernetes resources as your KCC resources now. So now you can have exactly the same OPA Rego rules applied on the cluster through Kubernetes or in a pipeline. So this common code paradigm allows consistent policy enforcement in different parts of the deployment lifecycle. And then KCC also links the lifecycle and methodology for managing both the application deployment and its supporting infrastructure. So instead of having your Terraform code that deploys the infrastructure, run that pipeline, and then go deploy the actual application code, let's say it might be as simple as a container, might be a set of cloud functions. You get everything kind of unified into one standard tool set, or one standard language, I guess, and deployment mechanism, which is primarily Git if you're using continuous deployment as well. And then, as I mentioned earlier, you can kind of create a tree of resources that get provisioned throughout the different layers as a combination of KCC and config sync, those two together really allow this kind of newer, sophisticated way of bootstrapping a tree of different resources for an environment. And that's pretty powerful. It's still kind of new. Not many have adopted that yet, but I think as we see more innovation in this space, we'll continue to see some additional ways of provisioning environments. A couple of lessons learned. KCC under the hood basically works the same way as Terraform, right? You have a service that needs permissions to the environment, and it makes API calls to your Google Cloud environment. The KCC resource coverage, KCC is still a pretty new tool. It lags Terraform. It tracks a version of the mainline Google Terraform provider, but it does not have many of the beta resources. So if you're using the Google beta provider, or if you're running gcloud beta resource, chances are it's not in KCC yet. I've noticed that they've made progress in kind of synchronizing the Terraform provider with KCC so that they're generating schemas from the Terraform. So if you look at the GitHub repository for Kubernetes config connector, you'll be able to see kind of how some of that works. KCC is just Kubernetes YAML. It doesn't have any built-in templating. So you have to make some decisions about how you're going to package resources. Sometimes, especially since it's a new tool, some groups that I've seen have been a little bit hesitant to commit to a single packaging mechanism. So it's something that I think needs to be discussed early on. It's not like Terraform that just has good modularity built into it. So you kind of got to think about that. If you're new to Kubernetes, KCC will also be challenging because there are it's not just learning how to write the YAML and apply that to Kubernetes. You also need to know how to package it. You need to know how to lint it, all these different things. So there are a lot of different tools that you need to know in the stack. That can be kind of a learning curve for someone just coming to Kubernetes or just coming to KCC if they don't have prior experience with Kubernetes. Pushing the deployment down into a Kubernetes controller has a lot of benefits because a lot of the complexity of the pipelines goes away. But at the same time, it makes debugging more complex because now you got to go to the Kubernetes cluster and figure out what the error is. There's a tool called Nomos that kind of helps with that, but still, what used to be right in front of you when you run the pipeline, errors that would come out of Terraform are now pushed down into a controller that runs on Kubernetes. So you don't have direct access to those errors, and it's a little bit harder to debug in general. And finally, just one thing I've noticed, there are a lot of config tools. There's Anthos config management, Anthos config controller, config sync, Kubernetes config connector. Lots of different names have this config in it. Some people might call this entire suite of tools KCC. So there are some nuances in the names. It's kind of hard to keep track of, in my opinion, just because there's a little bit of there's the open source tool name, there's the managed tool name, and it gets a little confusing at times. When choosing between Terraform and KCC, I mean, the obvious reason to use Terraform over KCC is that Terraform can provision resources on many different providers, whereas KCC is currently only focused on GCP resources. Terraform has a simple and easy to use domain-specific language. It's a custom language, but it's a very strong and expressive language, and it has developed quite a bit over the past few years into a pretty powerful language. You can have for loops and different kinds of kind of expressions within the language itself, whereas KCC is just simple YAML. Terraform does have pipeline and state that need to be managed, whereas KCC has kind of a tightly integrated deployment model that pairs nicely with other tools that run on Kubernetes cluster. And then finally, Terraform has really excellent packaging. I've kind of mentioned this earlier, but KCC depends on the packaging ecosystem for Kubernetes. There are some mature tools out there like Helm, but there are also other tools that it seems like there are many different tools. So you kind of got to figure out which one is the right packaging approach if you are going to adopt KCC. There's no concept of a module in KCC. You're just deploying individual resources. So that's something that is kind of lacking in KCC at the moment. And then for me, kind of like one thing that has really stood out is you don't need those escape hatches in order to acquire existing resources. So that's also kind of a new feature that is nice in KCC. So yeah, if you're using Kubernetes and GKE, I would recommend giving KCC some thought. It's still a fairly new tool, not as established as Terraform, but there are other tools out there in the ecosystem that are doing similar things to what KCC is doing, basically exposing Kubernetes resources. So there is innovation in this space, and it's interesting to see where it will go next.